All right, so today I'm gonna, I know that towards the end of last session there was some confusion about testing the means of two dependent samples. So there's a couple of students have posted that they were confused. So I thought that would be a good starting point for today to just clarify that particular test. Just to make sure that we have we fully understand how to solve dependent samples when comparing the means. Okay. All right. I think the confusion really arose from the use of this template here. Do you see the interactive template on your screen?
Yes.
Okay, good. So let me approach this the solution differently. That instead of using this template here, which I think the labels A and B becomes confusing when I use the before and after words. This was the before and then the after, and then the difference column is computed as A minus B, meaning this minus this. So let me approach this differently. And that is, if we go back to over here, right? When I started talking about dependent samples, we said that it reverts back to a one population t-test. All right. So let's approach this solution to a dependent samples problem from this angle. Hopefully that will clear up the confusion. Let's look at 1158. New problem. This particular problem is another example of comparing the means of two dependent samples. Dependent samples because here we're trying to compare the amount of income spent on housing that an economist selected a sample of 20 homeowners. So in this data set, and by the way, if you download, this particular Excel file is linked to Moodle now, so you don't have to key in the data that are presented in this worksheet. So if you haven't downloaded it yet, you can download it now so you can follow the discussion. So in here we have a sample of 20 homeowners in the New England, and then calculated these total housing costs as a percentage of the monthly income, and they're trying to compare the percentage of income spent on housing 5 years ago, so over here, versus now. Okay, so essentially they want to compare the mean of the percent of income spent on housing 5 years ago versus the mean now. So because the observations are paired or matched in terms of the homeowner, these samples are dependent. Okay, and because they are dependent samples, the analysis is now based on the difference for each period of observation. So let's compute the difference as 5 years ago minus now. Okay, so we have C23 minus D23 is the difference in the percent spent by homeowner 1 5 years ago compared to now. Now we'll copy this down. Okay, So we see here that most of the differences are actually positive. So that kind of at this point will perhaps will lead to the conclusion that percentage of income spent on housing 5 years ago is greater than what is spent now, right? But let's take a look at the keywords that this problem uses. Is it reasonable to conclude that the percent is less now than 5 years ago? Okay. So if this statement, by this statement, since we computed the difference column as 5 years ago minus now, that this one would be that the average difference is greater than 0. Okay, are we okay so far? That if we say that it is less now than 5 years ago, then that means that the numbers in the now column will be smaller than the numbers in the 5 years ago column. So that is represented in this manner. Are we clear so far? Right? Okay. So we set up the hypotheses. H sub 0, H1. H1 would say mu difference is greater than 0. Translation, 5 years ago, percentage is greater than now. Or conversely, you can say now is less than 5 years ago. All right. The null hypothesis would be less than or equal to 0. Okay. And since this is the sample size is small, only 20, and sigma is unknown, then this will use the t distribution. Okay, so far? So note that this hypothesis here is one population t test, as in the previous chapter. So in the one population t test, so let's go back to the template here. We'll go back to test for one population, right? And small samples, unknown population variance or unknown population standard deviation. Select that. And now let's go back to, let me copy this hypothesis setup. All right. So what do we need? What kind of information we need? First of all, the hypothesized mean difference is correct, right? Is set at 0. So that would be the number there. And then the direction of test is greater than. So that's good. We need to compute the sample mean. We need to compute the standard deviation. We know what the sample size is. That's 20. And then the significance level, I believe it is not stated, right? So we can, at this point, let's just assume, let's just use an alpha of 0.05. Let's assume that. So 0.05. Now we will need to compute the sample mean and the sample standard deviation. Okay, here's our data. Here's a sample data. So to compute the sample mean, we will use, so the X bar, we can use the function average and that group of observations. And then the standard deviation, S, we will compute S as equals STDEV and highlight the data set. Okay, so these are the two numbers that we will be using in this template. So X bar was 6.3, and then the sample standard deviation is 12.477, say 8. So using this output, we can now render a conclusion on the null hypothesis. If we look at the p-value generated by the data, here's the p-value. Okay, so p-value is equal to 0.018, and we assumed an alpha of 0.05. So with this, we will conclude to reject HO, and by rejecting HO, we will conclude that the percent spent, percent of income spent on housing, is that the, let me make sure that I'm using the correct statement. Yep. On housing is less now than 5 years ago. Okay. So this is actually the another approach to solving this problem, recognizing that dependent samples revert back to a one population t-test. So at least if you use this template here, we will avoid the confusion of having the two columns that we used last time. Having two columns using this template here. So does that make more sense now than last time?
Yes, quick question though. Why are we subtracting after from before as opposed to before from after like in the other problems?
Oh, you can still do, you can do the before, you can do the now, subtract the, this from this. But if you do that, then you will change this into a less than.
So would you still arrive at the same answer if that were the case?
Yes, you would. Correct.
Oh, okay.
Yeah, because this will be mostly negative, right?
Right.
If these are mostly negative, then that would be, the mu will be less than 0, and your test will yield the same p-value.
Oh, I see. Okay. Thank you.
Mm-hmm. All right, let's do one more and see. You do this on your own. Let's see. Let me pick up. All right, this one here, exercise 1147. And see if you can, nope, that's the one now. 1152. So in this problem, the president of American Insurance Institute wants to compare the yearly costs of auto insurance offered by two leading companies. He selects a sample of 15 families with some with only a single insured driver, others with several teenage drivers, and pays each family a stipend to contact the two companies and ask for a price quote. To make the data comparable, certain features such as deductible amounts, limits of liability are standardized. The sample information is reported below. So here's the data which I have entered here. At the 1% significant, 10% significance level, can we conclude that there is a difference in the amounts quoted? Okay. So again, this is an example of dependent samples because the observations, the quotes given by these two insurance companies, they're based on a particular family. So these numbers that you see here are matched or paired observations. Okay, so let me compute the difference here as, say, Progressive minus Geico. All right, so that would be this number minus this number. So how will you set up the hypotheses?
Well, HO would be it equals, or wait.
Okay.
Yeah, so HO would be it equals, and H1 would be does not equal.
Huh? Not equal? Okay, so what's missing here? Yeah, that's right. These are the two pairs of inequality because of this word difference here, which translates into not equal. This is good. But what's missing?
Mu.
Uh-huh. Okay. How about the right-hand side? What's missing there?
0.
Okay, good. All right, so once again, this is a one sample test. So you can use that template for the T one sample test. So we will say reject HO if you can use the p-value is less than alpha, or you can use the computed T if it is greater than the critical T. The absolute value of the computed T is greater than the critical T. Now, why is this absolute value? Well, remember that for a t-test, two-tailed test, that there are two areas of rejection. So you can just simply look at, this right side here. That's why we're converting the computed T into positive, so we can just compare that computed T to a critical T on the right side. Okay, so to carry out the test, we will need to compute the average, X bar, and we will also need to compute S. X bar is the average of this column, and S, let's see, make sure that there's no decimal there. All right, actually there's a decimal there. And then S the standard deviation of that group. So I'm just going to copy that and go back to the one sample t-test. Small samples, right? All right, so we'll change the direction of test to 1. Okay, so now we're consistent with the equal and not equal to. And then the sample mean is negative 246.33. S is 546.96. And sample size, what was the sample size?
15.
15, thank you. And significance level 0.5. So here's the p-value.
It's 0.10 in the problem, Renee.
Is it 0.10? Okay, thank you. All right. Still, the p-value is not less than the significance level. Okay. So here's the p-value. P-value is equal to 0.103. And then the computed t, the absolute value of computed t is 1.74. So 1.74, is this greater than the critical t of 1.761? The answer is no, it is not. All right. Also, if we look at the p-value is 0.103. Is this less than 0.10? The answer is no, it's not. So whether you use the computed statistic or the p-value as your decision rule, you should come to the same conclusion. That is, we will fail to reject the null hypothesis. And by failing to reject the null hypothesis, we are saying this, that the data does not support the rejection of the null hypothesis. So to answer the question posed in the problem, the answer is no. All right, we cannot conclude that there is a difference in the amounts quoted by these two insurance companies. Make sense? All right. Okay, so let's look at 1147. Oh, no, I don't have the data there, so let's move that out. 1142. Okay. Businesses, particularly those in the food preparation industry, such as General Mills, Kellogg, and Betty Crocker, regularly use coupons as brand allegiance builder to stimulate their retailing. There is uneasiness that the users of paper coupons are different from the users of e-coupons. One survey recorded the age of each person who redeemed a coupon along with the type, either electronic or paper. The sample of 35 e-coupon users had a mean age of 33.6 years with a standard deviation of 10.9, while similar sample of 25 traditional paper coupon clippers had a mean age of 39.5 with a standard deviation of 4.8. So I've summarized the information that's provided in the first three sentences over here. Okay, so this is the age, the average age of the 35 sampled who use e-coupons. And then this is the average age of the 35, or not 35 e-coupon. This should be 25, right? 25, 39, and 4.8. Okay, so that's the numbers are good now. Assume the population standard deviations are not the same. So essentially, the problem is telling us this, that the sigma squared 1, if we say this is 1, this is 2, is not equal to sigma squared 2, okay? Now, if we go back to the flow chart, tell me which branch of this flow chart are we going to follow. Oops. We know we're comparing two populations, right? Two groups. But the question is, what parameter are we comparing? What is it about these two groups are we comparing? Are comparing means? Are we comparing proportions? Or are we comparing variances? What do you think?
Are we comparing the means, the sample means?
Okay, why did you say that, Chris?
The last sentence, test
All right,
hypothesis, no difference in the mean ages.
All right, so it's explicitly stated in the problem, right? Question. So how do we convert this into symbols? And again, the keyword there, no difference. So we'll say mu1. So if we use 1 to denote the e-coupon group versus E2, mu2. What's the missing symbol between these two?
Does not equal.
Okay, not equal to, correct. All right. So this is our alternate hypothesis. Now, I think Doug suggested also to me after our session that about this, why does this translate to this? Can anybody tell me why these two are the same? Remember, you're a little bit of your algebra. If I move mu2 to the left side, what do? Well, I'll subtract both sides by mu2, right? So you still have the not equal to there, mu2 minus mu2, right? Therefore, mu1 minus mu2 not equal to 0. That's how this is equivalent to this. So the hypothesis would be, I'm just rewriting H1 here, mu1 minus mu2 is equal to 0, is not equal to 0, H1, H sub 0, mu1 minus mu2 equal to 0. Now, next question. Are the samples dependent or independent? Is there a one-to-one correspondence between, a person in the e-coupon group versus the paper coupon group? There's not. Nick says no. Therefore, these samples are independent. Okay, so going to the flow chart, we follow this path here, mean of two populations, independent samples. Okay, now let's look at the sample sizes. Are N1, N2 both greater than 30? Nope, one is smaller. All right, so because one is smaller, then we will go this way. And then the next question is, it's a little bit difficult to see that the writing is too small. So let me make this bigger. It says, are the population variances equal? Well, the problem stated that they're not. Okay? Because they're not, then we will follow this path here. It says, use the unpooled t-test. Okay? So the unpooled t-test is used when the variance of group 1 and the variance of group 2 are not equal. On the other hand, this pooled t-test that you see on the left side is when variance of group 1 is equal to the variance of group 2. So for this problem, we will be using the unpooled t-test. Unpooled t-test. So let me go back here. I want to copy all these the information. Okay, so let's go back to home and scroll down. We're comparing two populations, small samples. So there are two options there. One says small samples, unknown or unequal variances. The other one says small samples, equal variances. And based on the problem, it said that the variances are not equal. So we will select this option and we'll fill in the blank. So here's the data. Okay, so here's how we set up the hypotheses. The hypothesized difference is 0. And then the direction of test is equal to, not equal to. So we put 1 there. And then we can just use the name of the two groups, e-coupon, and then this one is paper coupon. The sample size, 35. Sample mean, 33.6. And then standard deviation is 10.9. The paper coupon, sample size of 25. The sample mean, 39.5. And then the sample standard deviation is 4.8.
And then the significance level is 0.01.
0.01? Okay,
Uh-huh.
thank you. Okay, so let me paste that here. So based on this output, what do we conclude about the null hypothesis? Alpha was stated as 0.01. P-value is equal to 0.00655. Or you can look at also this distribution here. Here's the computed value inside the reject HO region. So either using the computed statistic as your decision rule or the p-value as your decision rule, we will conclude to reject the null hypothesis. And by rejecting the null hypothesis, the answer to the question that was posed in the problem there is no difference in the mean ages of the two groups. The answer is there is a difference in the average age of the two groups. So if you were a marketing person and you were trying to promote your product and you are targeting the older group, right? The question is, which of these two coupon methods would be more useful for your target market?
The paper coupons.
So Shauna, paper coupons, why'd you say that? That's correct.
Probably because the mean is larger.
Yep, the average age of this group is larger. Okay, so from a marketing standpoint, you can use this as a way to support, say, your decision that if you are going to provide coupons to a particular target group, especially maybe the older group, this says that the older groups tend to prefer paper coupons. Any questions on this problem?
I have a question for the class.
Okay.
So when he goes through the flow chart, don't get hung up on the wording too much, because the wording on the template is a little bit different than what that is on the flow chart. So just think about what you're looking at when you select that template. Okay. So I think some of them are maybe getting confused with the wording on them.
As in the title of, are you talking about, are you referring to the title of the template, Doug? Like, for example, this one here?
Yeah, so like when it says on the flow chart to use the unpooled t-test, but on the template, it
Right.
says small sample or no variance equal.
Unequal variances. Yeah, that's why I had to, include this here.
Yeah.
Because this is really the key that tells you that in terms of using the template, whether to using, there's the key there.
Right. So are all you guys okay following all that? Okay,
All
good.
right, Chris. Okay, good. All right, so everything okay so far? Here's the
Pretty good.
output. Okay, here's the output. Okay, so paste that here. All right, so what's the p-value? P-value is over here. Okay, do we have an alpha for the problem?
0.05.
0.05. Okay, so based on the p-value, we will conclude to fail to reject the null hypothesis, right? If we look at the right, this is a right tail test. Right tail test because it's pointing to the right. Here's a computed Z inside the fail to reject HO region. By failing to reject the null hypothesis, what will we tell Advil in terms of the effectiveness of the new drug?
That it's not more effective?
Yep. Because when you fail to reject the null hypothesis, here it is. the new drug does not appear to be more effective, or the new formulation does not appear to be more effective. Okay? We're good? All right. How about this one? Each month, the National Association of Purchasing Managers publishes the NAPM Index. One of the questions asked on the survey to purchasing agents is, do you think economy is contracting? Last month, of the 300 responses, so this one says last month, of the 300 responses to the survey, 160 answered yes, so that would be this. To the question, this month, 170 of the 290 responses indicated they felt the economy was contracting. At the 0.5 significance level, can we conclude that a larger proportion of the agents believe the economy is contracting this month? So based on this, we're going to compare this greater than last. Okay? Or conversely, you can set it up this way. Last less than this month. Does that make sense? Either one is correct. But I would suggest that you look at, how the samples are set up, or how you set them up over here, and make it consistent with the way that you set up the alternate hypothesis. Okay? We clear there? So let's use this the way so that it's consistent with how we set up the hypotheses, the data. The null hypothesis would be, well, let's start with the alternate hypothesis first. Proportion of last is less than the proportion of this month. Last month greater than or equal to. All right. So the decision rule will be to reject the null hypothesis if the computed z is less than the critical z, or if p-value is less than alpha. All right. So we're doing a left tail test. All right. So this would be last month, and this would be this month. The hypothesized difference is still 0, but the direction of test will be 3. The sample size for last month is 300. Sample proportion is 160 divided by 300. And then this month, 290 and 170 divided by 290. And what was the significance level in the problem?
0.05.
0.05 still. All right, good. So here's the output. Let me make this a little bit smaller. Okay, so the p-value zero point 0.098. Okay, alpha is 0.05. So based on this, we will once again fail to reject the null hypothesis. And by failing to reject the null hypothesis, we're saying that the answer to this question, can we conclude that a larger proportion of the agents believe the economy is contracting this month? The answer is no, based on the data. Okay. Questions?
Professor, what was your reasoning for setting up the hypothesis the way you did?
Okay, yeah, the reason for that is the way that the data is presented, or at least that the data was organized here. Last month is first, and then this month is next. All right.
Oh, I see.
Now, if I reversed these two, then this one would be the appropriate setup.
Okay, gotcha. Thank you.
Sure. All right, so I think we've pretty much covered, we've done examples here. We have done examples here, but we haven't done any example over here, have we? Comparing the variances of two groups. All right, so let's do one. Let's go back to one of the earlier problems we did, which is, I believe, yeah, this one. Let's look at this problem here. All right. In this problem, this is actually a test of comparing the means of two groups, two independent groups. But the problem, at least this particular problem, told us to assume that the variances are not equal. Okay? Now, this one is just an assumption. So in statistical testing, assumptions need to be tested. So we can carry out a test of comparison of the variances to determine whether this assumption is justified. Okay? So let me just copy this and then paste that towards the end. All right, so this one is a variance test. So what we're going to do here is to, first of all, maybe there's a quicker way of it, deleting a certain all right. All right, so here's what we're going to do. We are going to test this assumption here. Okay, we'll test this. using this sample data, using the same data. So we'll set up the hypothesis as the variance of group 1 is equal to the variance of group 2. H1, the variance of group 1 is not equal to the variance of group 2. So that's how we set up the hypothesis. The decision rule will still be the same as before. We will compare a computed statistic, and in this case, the computed statistic is known as the F distribution. Or we can use the p-value as the decision rule. Okay? So let me copy these. And I'm back to home. Tests for comparing two populations, but this time we will be using comparing variances of two groups. All right, so this one uses the F test, the F distribution. So this is kind of a lead into the next chapter that we will cover next week, which is on the analysis of variance, and that uses the F distribution. All right. So here's the e-coupon group, and here's the paper coupon. The sample size, 35. Sample size for paper is 25. The sample standard deviation over here, 10.9, and 4.8 for the paper coupon. Now the test is equal to, not equal to. It is a two-tailed test. Then we will change this to 1. All right, so you see that the symbols now there is equal to, not equal to, consistent with this. Now look at the computed F, p-value. See that? P-value is 0. Therefore, the decision rule will be to reject the null hypothesis. And by rejecting the null hypothesis, we're saying that based on the data that is presented, the variances of these two groups are not equal. So when we used, let's go back to this particular problem here. When we used the unequal variances t-test, we use that because of this assumption here, right? Which we just tested that this assumption is justified or supported by data. And that's how we, the conclusion we made here. All right. Are we good?
Are we going to have to do both of those in certain problems? Like test
not necessarily. I don't think I'm going to ask you this, but I just wanted to show you that sometimes when assumptions are made when doing some testing, that there's a way to validate assumptions. But the F distribution is going to be covered next week.
Gotcha. Thank you.
Okay. Mhm. All right, so that pretty much sums up everything in chapter 11, comparing two populations. Any questions? Okay, so just giving you a heads up on for next week. The topic for next week will be an extension of what we've been going over so far. So hypothesis testing is what we've covered so far. Going back to chapter 10, we dealt with one population, right? And in that chapter, we tested a population mean, a population proportion, but this one, population standard deviation or sigma, we haven't covered this because this will be in a later chapter. In chapter 11, we looked at tests comparing the means of two groups, proportions of two groups, and variances of two groups. Now the question is, suppose we want to compare means of, say, 3 or more groups. You want to see if the average GPA of freshman, sophomore, junior, senior, graduate students, so that's 5 groups, if they are equal or not all equal. That will be covered in, so this was chapter 10, this is chapter 11, and in chapter 12 will be 3 or more groups. This will be in chapter 12. All right. That will be based on the ANOVA, which is an acronym for analysis of variance. And the procedure for testing will still follow the same steps we did for chapters 10 and 11. Okay, so that's kind of a peek into what we will be covering next week. Are there any questions?
Can you go back to exercise 34 really quick?
Sure.
What's going on with that?
Okay. 34, that one. Okay.
So you were saying you set up the hypothesis the way you did because of how the data was arranged?
Correct.
Last month and this month?
Uh-huh.
So if you were to reverse that, so it was this month, then last month, then you set it up like how you did at the top?
Correct.
Okay.
Correct. So you just make sure that, because when you enter this information into that template over here, that's how the critical Z is computed by subtracting this from that number.
Right. Okay.
Yeah, you have to make sure that how you set up the alternate hypothesis is consistent with how you input the information in the template.
Gotcha. Okay. Thank you.
Thanks for that question, because that is an important distinction and clarification.